So question number 4, we are going to do some function notation substitution. And it's important to recognize the parts of the function notation. So we have our outside part here. So f represents the outside part. Okay, and then we also have the x, which represents the inside part. And how that fits into our function flowchart is that inside the bracket x is what we're going to input. So looking at our flowchart here, this is what we're going to input into the function. Okay, the function is going to take that x, times it by -3, add 5. Okay, and then it's going to give our output y, which then represents the f in that function. So there's an outside and inside. And so this, we need to, when we're applying this, we need to do that for f. We also have a g. So our g of x, the g represents the outside. That is our 4x plus 1 expression. And then we have the inside. The x there is what's going to replace the x in the expression. So this is going to replace the x in this expression. Whatever's inside the brackets replaces the x in this expression. Just going to highlight this. This is my g. In red, I'm just going to highlight this as red. Okay, so then when we apply this to the problem below in A, we need to first of all recognize that there is a f function here. So then we identify the f function. It's going to be 5 minus 3 times x. So I'm going to leave the black open for x, and that's where we're going to do input our inside part. And so we go to the inside, that is 2 minus 5x. That's going to go into the x, so this is going to replace the x in the original expression. So we've done the f part of that. We then move on to the g part of that. So again, we need to identify the outside as g. So we go to the g expression. It's going to be 4 times blank, or x plus 1. And then we need to look inside. The inside just happens to be the exact same thing, but it is this 4x plus 1 that's going to then be embedded into that g function. Okay, and it's not multiplication, it's an embedding. What we're doing is replacing or embedding functions. So working this out, I end up with 5 minus 6 plus 15x. That's going to be equal to 16x plus 4 plus 1. When I solve this, on the left-hand side I get x. Sorry, on the right-hand side I'm going to get x. I'm going to subtract 5 from both sides. So if I take that and that, those are 0 pairs. So it looks like x is equal to -6. Okay. Get rid of that there. So x is equal to -6. Just checking my answer for 4. Question number 4. X is equal to -6. Okay. So this next part here, I'm just going to move this over so I have room to work. X is equal to -6. For part B, we're going to do the same thing. We need to first identify the outside part of the function. So this is my f. Okay, so then I go to my f expression originally. That's this part over here. And I'm going to take that f expression, and I'm going to start with that. 5 minus 3 times x. And I'm going to replace that x when I do the function notation. So I then look to the inside, it's 2x plus 2. So I replace the x with a 2x plus 2. So I've embedded that 2x plus 2 into that the f in the red. I've now done the f of x. I now move on to the g of x. So I go to my g function. My g function is 4. There's my outside, 4x plus 1. Okay, that's what I see here. So that's what I'm going to use for my g function. And then I look inside the g. There's an x squared, and that x squared then gets embedded into the g function. So I've now applied my function notation. I just need to simplify this. It does end up being a quadratic equation, which we haven't really learned how to solve this. Okay, so I'm going to show you how to solve a quadratic equation. So if you only get to this part and you get stuck, you don't know how to solve the x squared, that's okay. That's something we learned how to do in grade 11. But one of the things that we did in grade 10 is learn to factor. So I'll show you how factoring actually is involved in solving these types of equations. So first of all, I'm going to make it equal to 0 by moving everything to the other side. So I end up with plus 5 minus 6 is minus 1. So I'm going to add 1 to both sides. So I get plus 2. I'm going to add 6x to both sides. So I get plus 6x. Just making sure I balance my equation. Everything balances out. 5 minus 6. I add 1 to both sides to get plus 2. I get rid of the 6x with a plus 6x. And there's my equation. Okay. So I'm going to factor the 2 out. And the reason why, one of the reasons we learn to factor is to learn how to solve these types of equations. So 2x squared plus 3x plus 1, we learned how to factor that. I have 2x squared plus 1. That diagonal is 2x squared, so I need to split it up into 2x and 1x. And that gives me x plus 1 along the horizontal, 2x plus 1 along the vertical. So then my equation looks like this. 2 times 2x plus 1, x plus 1. Now, why would I do this? Well, the reason why I would do this is because since the left side is equal to 0, and I have multiplication, I just need to be able to multiply by 0 to make this equation equal, or solve the equation. So from here, I can just say, well, what x will make that bracket equal to 0? And the x that makes that bracket equal to 0 is going to be negative 1/2. So that's one of my solutions. I then look at the other bracket. If this bracket is equal to 0, that makes the right-hand side equal to 0, which then solves the equation. So I get another answer of x equals negative 1. And there's how I get my two answers. Now in grade 10, really you're only responsible to be able to get it to this point. We don't need to actually solve this yet.